Okay, so today we're going to learn about evaluating expressions. This is a very important concept. It builds and it prepares you for when you get to two-step equations in seventh grade and multi-step equations in eighth grade, and you'll just be doing this for a long time. Okay, so Farmer Marcel is harvesting fruit from her orchids. Nice. The picture at the right shows a symbolic expression for the number of pieces of fruit in her basket. It says substitute the value of each fruit to determine the total amount of fruit harvested. Okay, so you have apples, and you have 14 pears, and you have 30 cherries. Okay, so we say, it's 13 apples, 14 pears, 30 cherries. So we rewrite the expression using letters A, P, and C to represent each fruit. Okay. So, and we do this because even though like total, there's like 27, it's like 57 pieces of fruit, right? We also need to know like how many apples are there, how many pears, how many cherries, okay? So that's why it's important sometimes to make sure that you notate what is what. So an expression is a mathematical phrase that contains numbers, variables, and operations. A variable is used in mathematical expressions to represent an unknown numerical value. So these are the parts of the expression. So you have a variable, which can be any letter. So a lot of times that variable is going to be X, right? But you can use whatever variable you want to. So like if you're talking about boys, maybe you want to use B, okay? Or if you're talking about bananas, maybe you want to use B, okay? If you're talking about Chick-fil-A nuggets, maybe you want to use N, all right? Sometimes when you're using like X, like it starts to look like multiplication, so sometimes it's not good to use X. If you get that mixed up sometimes. All right, so the coefficient is the number that's always next to the variable, and the relationship between these two is that they are multiplying, okay? Like this is 4 times D. So together this makes a term, the 4 and a D, because it's a variable and a coefficient, so that is a term. The operation we're doing is here, which is subtraction. And then the constant is just a regular number that's being either added or subtracted, okay? So, recap. Regular number, 9, okay? Any number that's just being added or subtracted from something. We already know what an operation is. Variable, any letter, pick a letter, usually X. Coefficient, the number next to the variable. And please remember that these are multiplying, right? Because they're next to each other. If it looked like this, then, you would be dividing them. And so together, a coefficient and a variable make a term. I want to just point out that this is a term too. So even though 9 is a constant, it is a term. So like if you look at this one up here, 1, 2, 3. So this has like 3 terms, and this here, 4D minus 9 has 2 terms, okay? So when you have a coefficient and a variable together, that is a term. And then if you have just a number by itself, that is a term. So just a term is like the different parts of an expression that's being added or subtracted, like they're separated by operations. Okay, so let's replace. So we're going to evaluate these expressions. And so to do that, we're going to replace the variable with the number. So x is 7. Sorry. So x is 7 plus, parentheses, 3 plus 2. Okay, so we have to do that first. So it's going to be 7 plus 5. And then 7 plus 5 is 12. Okay. This one, I'm going to rewrite it as 2 times the quantity of 7 plus y is 3 minus 2. Okay, so again, remember the order operations. I got these parentheses here, so I have to handle that first. So I'm either going to multiply. There's nothing inside of them though, so I'm just multiplying these two. So this is going to become 14 plus 3 minus 2. Because addition and subtraction rank the same, now I'm just going from left to right. 14 plus 3 is 17, and 17 minus 2 is 15. Okay? The next one says y squared minus z squared. Okay? So obviously I'm going to do my exponents first. 3 times 3 is 9, minus 2 times 2, which is 4. And now I'm going to subtract those 2 and 9 minus 4 is 5. All right, so these look a little bit more complex, but we can still handle it. We're going to take it bit by bit. So you have 7 times 8 plus 5 times 6. So all I'm doing is right now is just replacing them, okay? And then plus 3. So 7 times 8 is 56, plus 5 times 6, which is 30, plus 3. So now that I've done that, I'm just going to add it from left to right. So I know when I add these two together, that's going to be 86, plus 3 is going to be 89, okay? So it says list all the parts of the expression in example number 4, okay? So terms, remember, I told you terms were like variables and coefficients together, okay? So that's going to be 7x and 5y, okay? And 3, okay? So these are all terms because they're different parts, but this is a term together, okay? Variables, I would say, are x and y. So that number 3 is not a variable because we know exactly what it is. The coefficient of the variable, so those are the numbers next to them, are 7. The 7 is next to the x and the 5 is next to the y. Constants are something that's being added or subtracted, but it doesn't have a variable. It's just a regular old number, so that's going to be 3, okay? Notice how I pulled apart my terms. So everything pretty much was a term, right? But then I took my terms and I separated into variables, coefficients, and then the constants, all right? Evaluating expressions is commonly used when substituting values into formulas to solve real-world problems. Use the formulas to complete the tables below by evaluating the expression. So we know this is a rectangle. So to find the formula of it, it's going to be area equals base times height, okay? So the expression that I'm going to use is A equals the base, okay, which is 6, and then the height, which is 2.7. Okay. So now I'm going to do 2.7 times 6. I know that 7 times 6 is 42. I carry the 4. 2 times 6 is 12, plus 4 is 16. So this is A equals, I got 162, right? This is going to be centimeters squared because I did centimeters times centimeters. So that's centimeters squared. Also, I know 162 is way too big, right? Because 2 times 6 is 12. So I know that this is 16.2. Remember, if this decimal is here, you have to move it over, okay? The next one, this is a square, so all the sides are the same. So the base and the height are the same. So we say S times S, like side times side, which is just 11 squared, which is also just 11 times 11, all right? And so that means that the area is going to be 121, which is 11 times 11 centimeters squared. Apply your understanding of evaluating expressions to answer the question below. Darius is building a fence around his rectangular butterfly garden. The length and width of his garden are shown below. Use the formula to find the perimeter of a rectangle, okay? So to do the perimeter here, so you can say the width is 4. Well, this is 8.3. I'm going to say this is 8.3. It's 4. And so basically, we're just going to add all the sides. That's all the perimeter is adding all the sides, okay? It doesn't, as long as it, it has sides. Like, you can't add a circle, okay? But, like a triangle, whatever, you just add all the sides. So you can think about it like that. And so when you do that, you're doubling the length, and then you're doubling the width. So that's where they get this from. See, because it's 2 of these, right? 2L and then 2W. So that's where they get this formula from. So either way, you can do it either way. So you can do P equals 2L, which that doesn't even look like it looks like a 1. So 2L plus 2W. So P equals 2 times 8.3 plus 2 times 4, okay? 2 times 4 is 8. And if I do 8.3, if I double that, 3 times 2 is 6, and 8 times 2 is 16. Okay, so this becomes P equals 16.6 plus 8. All right, and 16 plus 8 is 24. So I know that the perimeter is going to be 24.6 centimeters. Okay. And also you could have just added 8.3 and 8.3 and got 16.6, and then added 4 and 4 and got 8, and then you just add all of them. Okay. So the most important thing is that you know that you're adding all the sides. All right, two squares are shown below. Evaluate the expression b squared minus c squared to find the difference between the area of the two squares. So because this is a square, you know all the sides are the same, right? So that means every side measures 12, okay? So that means when you're finding the area, you can think about it like length times width. So you're going to get 12 times 12, okay? Or because it's like 12 times 12, you can also think about it as 12 squared, okay? So that's where they're getting that from, like this b squared. That's finding the area, and the same energy here, right? This is 5 times 5, okay? And we also know that like 5 times 5 is 5 squared, okay? And we know 5 times 5 is 25, and 12 squared is 144, okay? So when I look at this expression, so you said it was b squared minus c squared. We said the b is 12, so it's going to be 12 squared minus 5 squared. And so we said 12 squared is 144. It's 25, okay? So when I subtract those two, yes, I did. So 14 minus 5 is 9. 3 minus 2 is 1. So this is 119 centimeters squared, okay? So yeah, so that's the answer. That is the difference. So 119 centimeters. Okay, so for the next one, Renee made an error as she evaluated the expression 4x plus y squared when x equals 10 and y equals 2. Determine her error. Okay, so let me try to solve this on my own. Okay, and then I will compare. So she said that it was 4x, 4x plus y squared, okay? And so it's 4 times x, so this is 4 times 10 plus y squared, which is 2 squared, okay? So I'm going to get rid of my exponents first, so this is going to be 4 times 10 plus 4. Now I'm going to multiply, so this becomes 40. 4 times 10 is 40 plus 4, and then when I add that together, I get 44. Okay, how do you get 414 over here? So you have 4x plus y squared. Okay, I have that. And so then instead of multiplying them, okay, she just said, oh, this is 410 now. Okay, this is not 40. And then she did do 2 squared though. So then she added them and she got 414. So she made this into 410 instead of it being 40. So that was the mistake that was made. All right, so we're looking at this homework sheet. So I'm going to go through and solve all this. I think that you guys should pause it at this point and then work on it on your own. And I will go over each problem and keep kind of checking to see what the letters are represent, so then we can answer the question, what do variables ask each other when they meet? Okay, so we got 5x plus 9y. So I see x. I'm going to replace that with 8. Okay, so I'm doing 5 times 8. Sorry, 5 plus 9 times 11, okay? 5 times 8 is 40 plus 9 times 11 is 99. And then when I add those together, I get 139. And 139 is L. Okay, so I know that this is going to represent the letter L. This one, it says A cubed, so I'm going to do 3 minus C, which is 8, plus B, which is 6. You always want to kind of double check that you are picking like the right thing. Okay, because you see how this is kind of out of alphabetical order. So make sure that when it says C, you're using the actual C. So 3 times 3 is 9, and 9 times 3 is 27. So then this is 27 minus 8 plus 6, and now I can just go from left to right. So I have to do 27 minus 8. So I have to borrow. 17 minus 8 is 9, bring on the 1, so this is 19, right? And so now I have to do 19 plus 6, right? And 9 plus 6 is 5, carry the 1. So this one you should get 25 as your answer. And so the letter that matches with that is W, okay? So this is going to be a W. I'm trying to write these all in like maybe purple or something, okay? All right, so looking at the next one, I'm going to replace these values. So I got 12 minus 7 plus 10. So you have to do parentheses first. 12 minus 7 is 5. I have to multiply. 4 times 5 is 20. And plus 10 is 30, okay? And so when I look down, my answer for 30, my letter that correlates with 30 is O, okay? So far I have an L, a W, and an O. All right, number 4, where I see the Z, I'm going to replace it. All right, with 3, so this is going to be 8 minus 2 times 3 plus 3 plus X, which is 4, plus this, which is, okay? So the next thing I have to do is the parentheses. So when I add these together, this is going to be 13 minus 2 times 3 plus 13. Now this I have to multiply, so it's going to be 8 minus 6, 2 times 3 is 6, plus 13 times 3. 3 times 3 is 9, and so it's 39. So now I can just go from left to right. So I'm going to do 8 minus 6, which is 2, and then plus 39. So that's going to be 41, okay? So the answer for this one is 41. And let's see. The answer for this one is 41, and so that letter is E. All right. So again, remember you are making sure everything matches up. So this one is 8 cubed minus 4 times 2 plus 12, okay? So first I have to, so I know 8 cubed is 8 times 8 times 8, okay? I know 8 times 8 is 64. So 64 times 8. 4 times 8 is 2. You carry 32. You carry the 3. 6 times 8 is 48. Plus the 3 is 512. So this is going to be 512 minus 4 times 2, which is 8, plus 12. Okay, so I did my exponents first, and then I did my multiplication. So now I have to do my addition and subtraction. So I'm doing 512 minus 8. I know 12 minus 8 is 4. So that means 512 minus 8 is 504 plus 12. Okay. So 12 plus 4 is 16. So 516. So this one was pretty large, right? So you should have been kind of able to see that this one would be a little bit bigger than the other ones. Anyway, so the letter that represents is U. Okay. So I went ahead and started to work on these a little bit. So I plugged this in. So this is 12 times A, which is 9. And then 3 times B squared, and B is 4. So the first thing I have to do is the exponent. So I have to do 4 squared. 4 times 4 is 16. Okay, so now this is going to be 12 minus 3 times 6. So now I have to multiply because those rank the same. I just multiply on both sides, so I know that this is going to be 108 minus 16 times 3. 16 times 3 is 8, carry the 1, 4, so this is 48. Subtract these two. So this is 8 minus 8, which is 0, and then 10 minus 4, which is 6. And so this is 60. And so the answer for this one is A. Looking at the next one. So you can see B is 9 and C is 6. So I went ahead and plugged in those values. So the first thing you're going to do is what's in parentheses. So you're going to do 11 times this, which is 3. 3 times 6 plus 9, which is 15. Okay, so now you have to multiply. So I know that this is going to become 33 plus 15 times 3. So 15, 3 is going to be 3 times 5 is 5, carry the 1. 1 times 4, so this is 45. Okay, so now I have to add these two, so you have 33 plus 45. 3 plus 5 is 8, so this is 78. And the letter that represents 78 is going to be H. All right, so looking at the next ones, you see you have something cubed, but it's not as big as the other one. So this is going to be 3 cubed, which we did over here, right? 3 cubed over here. And then H squared, so H was 5. Anyway, so we know 3 cubed was 27 because I already did that over there, okay? And then is 5 squared is 25 plus 8. After you do this, then you just go from left to right because subtraction and addition rank the same. So 27 minus 25 is 2. And if you add 8 to that, that's 10. So that means the number that represents, the letter that represents number 8 is going to be the letter T. So now we only have 2 more left, so we're looking at 9. So for number 9, I think I'm going to keep it right now, y'all. So I just drew a picture just to kind of show you like a rectangle. But we're going to use this. But anyways, remember if you're finding the perimeter, you're just adding all the sides, okay? So P equals L plus 2W. Now, again, you may want to use a uppercase L because that lowercase L just looks like a 1. So P equals 2 times 9 plus 2 times 3. That 3 looks crazy. So 2 times 9 is 18 plus 2 times 3, which is 6. When I add these two together, the perimeter for this is going to be 24, okay? And the letter that represents 24 is R. Last but not least, the screen of the tablet is shaped like a rectangle. Find the area when the base is 7 and the height is 11, okay? So we know if we have to find the perimeter, we can just add all the sides. And nobody asked us for that, so we're doing area equals base times height. And so B is 7, the height is 11, and 7 times 11 is 77. And the letter that represents 77 is Y. So the question was, I put the riddle at the bottom, what do variables ask each other when meet? They say, what, like what? It should be what's, like after the T should be apostrophe S. So what's your letter? what are they talking about with your letter? I guess like, oh, it's like, what's your name? Like, when you meet somebody, like, hey, what's your name? What's your letter? But isn't that like a giveaway? Like, if I see you and like you're a letter, you know what I mean? Like you're a variable, so I already know like what your letter is by looking at you. But maybe I shouldn't assume. Maybe I shouldn't assume, okay, that like, maybe you're not really, a letter. Like maybe this is a one, okay? Or maybe this is an L. Like I don't know, okay? So let's not judge them. All right? Really quick, y'all. A couple tips. So make sure that you remember that if you have a letter and a number, two letters next to each other, or like a letter and a variable next to each other, please know that this is multiplying. Okay, that's a major key. So important, all right? Also, just keep in mind that like when you're like plugging in values, you just need to double check that you're plugging in the correct values. I think that like especially like when they're out of order like this, like you see the Z here was 3, but it's like you really want to go from like, okay, this is 4, and then this is 9 because it's an alphabetical order. So resist that urge and make sure you're just checking each time, even after you fill it in, that you're going back to double check, because I make mistakes all the time in math, so I'm not above going back and check my work. Okay, I'm really going this time, y'all. Bye.